This conference will now be recorded.
Okay. We were in this topic now. So let's slowly keep starting. The others might come and join. Okay. So here we were talking about vector is done, and then we switch it to set. And then after that, side in set also we have seen a couple of scenarios. Then these are simple things like probably this is for adding some element to a set. Okay, like usually you should use plus equal to. Let me check it. Okay, that's what this is. Maybe we can quickly check this. Let me open it. So we were already working on set sometime back. And let me remove all this stuff. Suppose I want to add some more data. So we can say something like where some set2 equal to set plus some 10. Okay. Just trying to add 10. Let's see. So println of set2 and let me just run this. And you can see there 10 is added to the set as a decimal element because right. When you have the highest level of this thing, right, data type, all the data in that will be converted to the higher type. Okay? That's what we have discussed sometime back. You know that, right? So now we can see this is a simple way of adding an element to a set. Okay, probably you might add a set as well. There are different ways, right? We have discussed sometime back. So this is appending data to the set. Suppose if let us see if we can remove some data from the set as well. So similarly, likewise, how I have tried to add some data by adding plus with them. Let me try to put minus and remove the data here. So what happens now? Let me run this. So after that, I think there is no impact of minus on this. Probably set2. I think I am saying set minus 10, right? I should say set2 minus 10. That is one thing. Second thing is I should print 3, not 2. Those are the differences. So let us see. Definitely this is working. See, the easiest way. So if you want to append some data to set, you can apply plus, and if you want to remove some data from the set, you can do it like this as well. So this is one more a quick update on this, like adding data and removing data from the set. And also you can do some different kinds of operations like difference, union, because this is set, right? Whenever a set comes, we can apply all that set operations, intersection. You have done something in the school days, right? This is something which is much more simpler than many mathematical things, sets, union, intersection. You have remembered, right? All that stuff, relations like one to many to one. Usually people explain that with some diagrams, Venn diagrams, what we call technically in maths. So the same stuff it's coming in the form of what our collections. With those whatever the methods we have learned somewhere in the schooling, those methods we can apply here. But the point is, you don't need to be right, that smart to understand these things. Okay, because here the process is so simple. Suppose you have two sets. Okay, you can see that we have set 1 and set 2. Of course, the data is same, and usually we cannot have duplicates there whenever you try to add duplicates to a set. I'll do one thing. instead of depending on same set, same data, let me add some other different data here, something like 10. So let some elements might be common, let some elements might be distinct. Okay, something like let me put it as 20. And also I'm trying to put unique data just for right, comparison purpose, unique and similar type. That is also one more important thing. So here let me add some 40. Let some data might be same, let some data might be different. Now we have two sets with some elements are common between these two sets, some are distinct or different or unique in between these two sets. So what I would like to do is I would like to quickly do some kind of this set operations. Usually we can apply same operations on any kind of set. It's not just only this set. You can apply this on the implementation classes. You say has set, you say that list set, or you say tree set or bit set. You can apply these functions, whichever you are seeing here on this all the implementation classes. The point is, no, we have seen some difference when we are working with set. What is that? This is a quite catchy thing. What is it? Suppose you see, sir, when you look at the listing, you can apply sorting on lists. Correct, right? Those sets are there which are specific to the list. But right, here when you talk about set that sort by sorted, sort with, just a quick idea, like those methods we cannot apply or we don't apply on set. Why? Why, sir? Because set doesn't preserve insertion order. We have discussed very clearly about that. Then these methods, what we are seeing here again. So that's about listing. Now set has something really specific to this, like this intersection stuff, this union stuff. These are more specific to the set actually, more used applied on set. Might be even if they were there in the list also, more than list, it is very much applicable for set here. You can see something like you can see there the union stuff. So something like you can say set, you can compare that with set. When you say union, what happens? The elements of set and set 4 get merged into one more new set that is returned. You have to assign that to one more set like this. And you can do the same these things yourself, sir, because these are not really tough or really challenging here. These are very straightforward methods. You can try to apply them, okay, directly. You have union, you have intersection. I'll just show you those actually the something which are more applicable on sets. Usually in Python also I see these are which is common only for we apply for sets actually, which is not applicable for list and tuple in Python. I'm just giving you a quick heads up, like how these are important here. So you see intersection, you can see there intersect. Usually, right, we apply more on sets here. Similarly, difference, even these are there. If I remember, we have seen such methods even on list, but no, based on the collection or data structure, some methods are very more applicable to certain kind of data structures, okay, even though they might be there even for list also. So diff, you can see that diff, it's more like doing a subtraction, set 1 minus set 2. Somewhere in the mathematics we have observed in the school days, right? Union, you have seen, right, applying that union function or that symbol. And we have seen intersection, like the upper trough, lower trough. You have remembered that stuff. The same thing we are applying here, right? So similar kind of operations we are doing on the sets here. Okay, so you can try for what, sir? You can try for intersection, you can try for difference. Many other methods are there. You can check them, because we had almost spent some 3 to 4 sessions to understand most of these methods, which were there in the traversable, iterable stuff. Okay, those interfaces. Most of these methods are directly inherited to this implementation class from the parent rights, probably from the set, probably from the extra one is what, probably from the iterable, probably from the traversable. Okay, so you can see diff, filter, map, all this stuff is same. Flatten, we have seen it. Fold right, fold left. This stuff we have discussed. Group by we have seen, grouped, all this stuff. Then head and tail, we have discussed this stuff as well, how it works. Intersect, just now I brought those things to your notice. In it also we had discussed while discussing this stuff. Last and, right, that stuff we have discussed. I'm just going through the methods so that you might get a quick idea. Okay, you can conclude, okay, we have gone through this just to get that a quick understanding whether we have implemented those methods or not. Probably, if you remember, the first 4 sessions we have exclusively dedicated understanding the methods. Okay, now the same methods now you can apply on set as well. Okay, so max min, it's not that tough. We didn't try with MK string, but anyhow, nothing to worry about that part. Reduce, we have seen discussed how reduce works. Then scan, probably we didn't discuss, but not an issue. Size we know, slice we know. We can apply slicing on set as well. Okay, that is also there. Subset, okay, part of set, like it's kind of slicing, okay, but much more different from that. Parameters will be different here. And then take is anyhow we have seen take concept. Iterator thing also I have discussed in the last session. Okay, and these are all conversion functions. Observe carefully. To list, to map, to sequence. We have done a kind of workaround in the last session, like converting set to map to set, and removing duplicates. We have discussed that stuff as well. Okay, to traversable, if you want, you can convert set to that the parent type as well. That's also possible, sir. Okay, internally it uses the implementation class. You might ask me a question, right, we had discussed that we cannot create object for try. How can we create right, an object? So directly it won't create object for that, right? But the implementation class, whatever that is there, that object is assigned. Okay, or there will be a companion class behind. You can see this set is a trait. Still we are creating an object for that, and we know how it works. Behind this there will be a companion object, and that companion object takes care of creating objects. And then in that, probably it uses creating object for implementation class, not directly to the trait. That happens there. Okay, if you have a doubt, this is an open source Scala. You can go into that API, and you can go to the set class and see the companion object, how it is implemented. You get that idea. Got it, right? And then the zip methods we have seen, very well. Flag map, you are much more familiar because we are hearing these methods a lot of times. These are comparative methods like equal, get, and not equal, all this stuff. This wait, notify, these are all coming from the parent, like any. Probably these are used from, in the multi-threading thing. Okay, multi-threading means usually when you have a synchronization concept, these methods are applicable. In one session I will discuss about that stuff. In multi-threading, anyhow, when I discuss that topic, I will explain these methods. Notify, all, wait. Okay, and then some other equals, anyhow, about that stuff. As in stands up, we have used a couple of times in this discussion so far. So when you look at this list of methods here, which are present in this, you might understand that most of these methods we had discussed, we had applied on list. So you can try that with on set as well. Okay, because already as we have spent some time, I don't want again taking again applying same methods again and again. You can try the same methods on set as well. This is a quick bite for everyone. Okay, is that clear to all of you, sir? Is that good for you? Okay.
Yes, sir.
Okay, right. So this is a quick idea about set thing. One more stuff is adding something to a set, like applying plus and applying minus. We have also seen colon plus colon. Okay, that stuff as well, appending, prepending, when we discuss about list. But probably here we don't do that because set doesn't use the implementation underlying data structure as a linked list. So when you don't have that, this appending, prepending generally is not, I don't think that will work here. Like, you can see there something like when I try to put it or something before this also, this, I don't think this will work here. Got it, right? Might be if you ask me a question, but here I think this will work. Plus equal to should work. Okay. Okay, minus equal. Let me just check it because I remember using sometime about this also. Okay, not right. Okay, I think I'm just getting quick idea for you that colon plus colon. Usually they are for appending and prepending. So that's why list has that kind of this thing underlying data structure as it is linked list. But set don't use linked list. That's why that colon plus colon don't work here. Okay, got it right. So that's why we can use plus minus here for appending or right for removing data. And also here there is no point of appending or prepending because if you try to add prepend or append, there is no guarantee that that will be added first or that will be added last because there is no insertion order is not preserved here. That is very important point you have to remember. So hope that's clear for everyone, sir. Anybody has any doubt on that? Understood now? One
Yes,
minute,
sir.
sir.
We can move ahead.
Okay, thank you. We are running out of battery here. Fine, sir. So got it right. I just want to talk about this stuff as well. Why don't you test this few scenarios, sir? Other methods you tried, sir. You can try it yourself. Other methods. Please test this, like adding and removing stuff here quickly. And you can try remaining methods as well. That intersection, that difference. You can also go with all that stuff, sir. That map stuff, that filter stuff, that flat map stuff. Okay, reduce stuff. You can try all that. Even slicing. Those are most useful for you. But this you can try it yourself, sir. Please try this, sir. Please test it. Then I will switch to the hierarchy now. I will talk about HashSet. And today probably we'll try to finish the 3 implementation classes of set. Is it tested, sir? Hope you finished testing this, sir. I am copying this and pasting here if you wish. Today I think we are missing Suresh, probably. No issues. Okay, sir. I will switch to the next scenario. So we move to the next one, sir. Okay. Let me open the Scala collections hierarchy so that probably, if possible, we'll have one session on this Saturday, sir. So to cover up the miscellaneous as well, we will plan one session on Saturday if it is fine for our people. Okay? So soon we will start Sparkle. You can see how interesting it is.
Sure, sir. We can have this session, but please consider at the evening time, please.
Sure, sir. Sure, sir. Definitely. So now let's open the hierarchy. We know we have an idea about it because we have seen this number of times. It's more or less right. At least stop looking those many times. I don't think it's difficult for us to remember. That is also one reason, because while this you have to remember this stuff, sir. Trust me. Why? If you can learn all this properly here, means you are covering most of Java part as well. It's not just Scala you are covering. You are also covering Java. Being a Hadoop, guy, it's not just we need Scala. We need Scala, Java, and Python also, sir. So that's why even though sometimes people don't ask questions in interviews, this will help you to quickly upskill Java as well. Got it right? So that way, going to be very helpful to you, sir. 1 minute. I'm not. This is not getting to trying to open it. This fellow don't need slides here. So this all. Where is the? Yeah. Now I got to the right thing. See, sir. We know very well by looking at this. Why this many times I will bring in this is because many people just have a simple idea about even some people, they don't bother about traversable and iterable where this hierarchy exactly starts. And if you don't have this hierarchy in your mind, there will be a lot of internal conversions happening. There is a lot of parameters which are passed as traversable, iterable, set, and map. And in such cases, when that kind of casting is applied and when you have such parameters, that will confuse you, sir. The concept of loose coupling, that this is going to help you to loosely couple your objects. Even for methods, if I pass traversable, to that traversable parameter, I can pass iterable, I can pass set, I can pass map, I can pass HashSet. Any object at the bottom level can be passed as a value to traversable. Got it right? Means if this is a very big bucket and if these are small buckets, you can put this small bucket into this big bucket. A quick point to remember. And when you know this hierarchy, then you get a better understanding or better hold on this methods, everything. Many people, they don't even understand when they look at parameters, why this parameter is there in that method. That's where you are missing the expertization. So logic is, it differs from person to person, but technically being good depends on us only, sir. Got it right? So now coming back to the set here today, our focus is more on what, sir? We are going to exclusively focus on this area. I'm going a little slow, so don't mind, sir. Just for your this thing only. For all of us, good only. Okay. Now we know set. Now we got some idea. The quick things about set is we understood a couple of things. It doesn't allow duplicates, no insertion order. It doesn't use any indexing. And also one more thing is what, sir? It uses internally. It uses something called hash map or hash table kind of data structure. Hash table or hash map is something which uses key and value pairs internally. But in a set, you don't have key value pair. Your values are stored as objects, but without in an order. It won't follow any order. We don't guarantee the order. So that is a big idea. And no duplicates. That is one more important thing. That is the primary, this thing about set. Now set has a couple of kits here. Set has set, sorted set, and bit set, and listed set, and set. Among this, sorted set is again what it is not a implementation class. It is a type here. No, whatever in blue color, right? This light blue, these are all types. Dark blue, these are all implementation classes. To be clear. Now the point is, let's what we do is let's have a quick addition to this. I'm just only for the sake of your clarity, I'm adding these things. Okay. So now when we talk about the implementation classes of set, the direct implementation is right. Set has these IMPL classes. What is that? These are IMPL classes direct. No, right? One is what, sir? HashSet, and then bit set, and then list set, bit set, and list set. These are all direct IMPL classes. And this set has one more child trait, one more child trait, which is what we call sorted set. And this guy has one kid. Who is that? That guy is 3 set. Now get a quick idea here. These guys don't sort data. Okay, that concept of couple of things, right? No duplicates, inserts not or not preserved. That is quite common for all this implementation. No, I'm sorry. Except for this. List set don't follow that. What is that? This will you follow sorted order. I mean, sorry, insertion order, not sorted. This will preserve the insertion order. But other implementation classes has set, bit set, and then tree set. This doesn't preserve the insertion order. And sorted set is not implementation class. It is actually a trait. You got this clearly. So among all this, none of these classes preserves insertion order except list set. Remember, we'll talk it one by one. We will have a detailed discussion about hash set, about list set, about tree set. Bit set, we will take it as miscellaneous. I will discuss on Saturday. Okay, few things I want to keep it for the right Saturday session. I'm focusing on the most important popular or most used classes. So this will preserve insertion order. That is also one more. That is exception here. Preserve insertion order. Preserving insertion order is different. Sorting is different. Don't get confused. Preserving insertion order means whatever the elements you enter into that set, they are stored as is. The order is not modified. Sort means suppose you have 5, 4, 1, 2 like that. Then it starts with 1, 2, 4, 5. But that is different. That is sorting. Preserving insertion order means I am entering 5, 4, 1, 2. Then the elements are stored as is. That is preserving insertion order. You got it, right? So that's the difference. Now, what is this sorted set here? It is a child trait, okay, of right, child trait. By the time we finish this, this whole this tree should be in your mind, sir. See, you see, this tree should be in your mind when we finish our discussion of all these hierarchies. Got it, right? So that's what you have to do. The advantage, the same tree, almost a similar tree you can see in Java. Got it, right? So that will help you to quickly migrate to Java as well. Okay. Now going back to our discussion now. What is it, sir? Now we are not into the Java, sir. Just giving you a heads up to that. That's all. This is a child, right? If you want to go for sorting of elements, so sorted set is if you want to sort elements according to some natural sorting. Natural sorting is always ascending order, sir. If you want descending order, you can do something there. Nothing to worry about it. Okay, we can apply some kind of comparators. We have discussed somewhere on list also such kind of scenario. Similar customized. If it is right, if you want descending, we can do something there on the tree set. Okay, we'll talk about it again. So, but the point is, this is a child trait. Usually, what this will do. This is used to sort elements according to sorts elements according to natural sorting. What do you mean by natural sorting, sir? What is natural sorting? Ascending order, sir. Always it is ascending. Descending means customized again. In this world, there are just two sortings only: ascending or descending. How complex the algorithm may apply, these are the only two sorts what we have. There is no other sort in this world itself, entire world. Okay, and that ascending always treated as natural sorting. Okay, so now you got clarity, right? This set, right? Now what is set? This has couple of implementation classes. This has set, this set, and tree set. They don't preserve insertion order. And differences all doesn't one common quality, no duplicate business. What is that, sir? No duplicate business. I'm just writing like that just for like that, nothing to. So that's what set major primary constraint of set is that no duplicates. Other things here and there that might change depending on implementation classes. Okay, Insertion order, most of the implementation classes don't preserve insertion order except list set. Suppose if you want to sort elements according to natural sorting, then you can go for sorted set. Okay, so directly you have a tree set. You don't need to apply that sorted method, sorted by method, sorted with method. If you have a question, if you feel that, okay, I am missing some sorting on sets, so how can I do this? Shall I convert to the list and can I do plain sorting on list? Not necessary. This tree set, this guy is there for us. This guy will do that that thing. Okay, what is that? It will sort elements according to natural sorting. Okay, so finally, this is a quick idea about the whole hierarchy. By looking at it, you might understand the stuff. Okay, now I'm starting with HashSet. This fellow, who is that? Let us start with HashSet now. This guy is a child and IMPL class. Again, I'm just discussing for more understanding purpose. By now, you might have a clear picture of this whole set family. But again, we are just trying to do a deeper analysis. HashSet. This guy is an implementation class of many guys. Okay, this guy is IM class of set, gamma, and then what? Iterable, and then traversable. All these are parents of what is that, sir? These guys are parents of HashSet, sir. Remember. And then next one. Second thing, same properties whichever we have discussed for set, no duplicates. That is the quite common feature. Insertion order not preserved. One more thing. Okay, again I am discussing points class wise, so that if any minute changes were there, so that you can identify them and you can observe them carefully. Insertion order not preserved. Okay, next one. What else we can discuss about sets? So dynamic, no doubt. Collections means dynamic set. They are dynamic. They are growable and shrinkable. Okay, and then what else we can add to this? This doesn't have indexing, that stuff. No indexing here. No index business. No duplicate business. Okay, got it right. So these are the important points you need to remember. Okay, now I'm going to the simple examples, some small and quick examples, so that you get a quick idea. Other methods, again, the map stuff, the filter stuff, whatever we have, I told you, those methods we can apply on this. The union, the intersect, the that stuff you can directly apply on HashSet as well. Okay, most of those methods which we have seen on set are applicable for most of these implementation classes, almost all these implementation classes. Okay, so now the point is, let us quickly test this. Null insertion is possible. Nulls anyhow are always allowed. Okay, that is also one more stuff, and it is heterogeneous. One more point, if we wish to add to this. Okay, so if you want to do paper filling as per our semester exams, okay, what is this, sir? But we are not doing paper filling. It's just a quick joke. I don't know. It might be a joke. So one more stuff is what, sir? It can be heterogeneous or homogeneous. It's up to you if you want it. So generally it is heterogeneous. A heterogeneous object can have homogeneous data. Means if it's up to you, if you want to have homogeneous or heterogeneous. But the recommended always is what, sir? Heterogeneous or homogeneous? It's always good to have homogeneous data than a heterogeneous data. And you can ask me a question. Why, sir? Because I told you clearly a number of times. Sir. When you have heterogeneous data, you have to be always careful. But if you have a homogeneous data, we don't have casting issues. It's like, a quick example to remember. When you have multiple casts in one room, there is a possibility of having issues sometimes. I'm not, pointing anything here, just our concept here. Suppose you have everybody is belonging to the same caste, whatever caste it might be. So then you see the trouble is less here, correct? Right nowadays we are seeing all this kind. Same thing we can apply for technical thing that is there here also. Got it right? When you have heterogeneous data, there is a possibility of casting issues. When you have homogeneous data, we don't have such issues. There is no classification of that kind of stuff. Okay, so that is the advantage. Now quickly what we do is we'll take one example and then let's try to implement that stuff, sir. So what do we do? Stuff. I will just remove this stuff, sir. I think it's little okay. It's not that good to see there. And we can do one thing instead of removing the whole stuff. What I can do is you can just put some HashSet here. But one thing is you can see an error. when it is set, we don't have an error. But when I try to create HashSet object, I'm seeing an error. The reason is simple, sir. Whenever you see such thing, when you try to create an object, the problem is here we should import that package, because when you HashSet has a conflict, this guy is there in two packages. Let me just show you here. When it is coming from two packages, see sir, it is there in mutable and it is there in immutable. It is there in util. It is there in java.util. This is directly a Java session, Java class actually, not Scala, but still HashSet is there in even Java. You know, right? As per interoperability, Scala can directly use Java implementation classes as well. That's what happens in our project. There is a mix of Java classes, mix of Scala classes. Sometimes they try to import directly Java packages into Scala code and do something. But anyhow, why we have this problem here is there is a conflict here. The same class is available in two packages, and you have to make a decision. Now, what is the hierarchy we are looking? Are we looking into the immutable? Are we looking into the mutable? Which one should we choose here? Means definitely we should go for immutable. It's not the, what is that, sir? Mutable, because now our topic is not mutable, but the same thing. If you import mutable and try to do the same stuff, the difference, mutable cannot be modified, immutable can be modified. That is the difference. Other than that, probably the concept is almost similar for both. Okay, and then that's why I told you, if you are really familiar with one hierarchy, it's almost familiar for all hierarchies. So now you can see this. Of course, I didn't sort the data, but so sort in sense, so you can see there. I just gave data like this. It's a sorted form, but we cannot be sure that it will be the same. If when you print it, see, let me just try to print it in such an order. We don't guarantee, it might be, it may or might not be. It depends on hash code. It depends on these addresses of each element, because here every element internally in this collection is treated as what? It is treated as an object. Okay, now let me try to run this. Let me run this. And you can see there the insertion order is not preserved here. Can you see this, sir? You got it? Right. Understood, sir? So insertion order is not preserved, because that's what we had a discussion. Second thing, I can keep adding data. We don't have a problem, dynamic. And then what else we have discussed? Suppose if I try to put duplicates, you can see, sir, I try to add duplicates. Sir. Now you can see, sir. Let me try to print it. No duplicates. You can test every feature of this data structures. This is what you need to understand first, sir. Trust me. Okay, without having these understanding, if you directly go jump start doing coding, then there will be a lot of confusion with the coding, because coding is not difficult, but the understanding the rules is important. That is where majority of the developers miss that point. That's why they struggle with their projects. That's what I am seeing. Okay, right. So you can see there, sir, it will definitely would have removed duplicates. That's what the nature of set is, right? That's what. And we can see it is dynamic. I can keep adding as many as possible, and insertion order not preserved. Okay, and what else, sir? Right, no duplicates. So that's the quick idea about HashSet. Maybe if you want, you can add more elements. And also, suppose if I want to add okay, like like say, similar case of set, like if I want to add element by element to the set, you can apply plus here, and then you can do the same stuff here as well. And you can print that stuff, and then what is that? Adding elements at a time. Other methods you can apply same here, sir. You can apply iterable, whatever I have shown in the last session. The same iterable you can apply here. Maybe just quickly run this and see whether 100 is added to this set or not. Okay, just running it. It's taking some time, sir. No issues. Hope you are following, right, sir? I think all of you are good so far, right? Right. My goal is by the time we finish this Okay, this collection hierarchy, every entity that is there in that hierarchy, you should have a perfect idea. You should just take a pen and paper and simply draw that hierarchy like that. What you have to be. I know that's not difficult for you, being working people. This even freshers, I see that they can do that. Now another thing, I'm trying to remove the data set. You can see there 100 is added there, appended, and minus you can apply the same minus stuff here as well. Okay, I'm just taking it as 3. Right? Why we try to create a new object every time? Right? The reason clearly, right, sir? That's what these people have suggested. When you are trying to do some kind of operation on immutable objects, try to, because as we modify, a new object is created in memory, right? I have discussed same concept in string. If you want, I can again explain with right, in the paint. Should I, or you remember that stuff? No, right? Whenever you try to modify, it will try to create a new object. That old object will be there intact, and this address of new object is assigned to this reference now. Okay, you got the point, right? So that old object anyhow, that is pointed by set. This new object is pointed by set2. Understood, right, sir? I modified it. Then that's what you have to do always when it is immutable. Okay. So now you can see the what happens here. Okay. Maybe I will just quickly test few methods, sir. Like if you want, I will apply map or filter once. You can see there. I should print 3 here, sir, not 2. That's why it's showing 100 again. When I print 3, set 3, because we have applied on set 3 here, that minus stuff. Now you can see the output. You can see the output, sir. Right. The issue is with my charger. When I am doing charging, it will be little slow. Now you can see 100 is again removed. Again, it is the old object as is. Can you see that? Now, maybe you can apply iterator. Right, that method iterator we have done day before yesterday. That you can apply here on this. You can apply for on this. You can apply for each on that. That kind of implementation is same. Sir. You can apply map, flat map filter. You can apply all other methods which we have seen, like this something set operations which are specific to set. Okay, even they are there for list also, sir. We don't need to generalize this. Okay, we don't need to make it exclusive. That is generalized. Okay, those are applicable even for list also. Okay. So that's the we can quickly test this, sir. That is enough for us on HashSet. We need to understand the basic features and how to create that object. Other stuff we had a discussion, but on Saturday let's make it as workaround. In that, what we do is we'll take some kind of business logics. Okay, we try to apply on that some kind of logic building session. Also, we'll make it on these collections also. Okay, is that fine for you? As long as you are patient, I am patient. We'll try that. Okay. On Saturday, I'll try to plan. Not try. Probably I'm trying to. I'll fix a session. So please try this, sir. Test it quickly. This is a quick idea about HashSet. Okay. Make a note of it, sir. Got clarity here, right? Make a note of it. Not note. Please test it. That's all. Nothing more than that. No, I am not implementing other methods because it's not like I don't want to. But we had already seen applying on list. So that now let's finish understanding all these classes. Then later on Saturday we'll do a workaround on all this. Test it, then I will move to the next one. And confirm, please confirm.
Can't we change set? I mean that here set that hash set. Is it? Does it allow to change that set?
This one is immutable, Madhu. This is immutable.
Okay.
So the entity is immutable. You cannot
doesn't allow to change.
Does it?
But I think it will be modified if you change that val to var. Though we are implementing it immutable,
okay,
but we can change that.
No, might be if you put var, that might be there, but in this case, when it is immutable, internally in memory, a new object is created. That where, even though you put where here, you might not see an error. Okay, let me just talk about your case here. So when it is immutable, there is a basic rule that is applicable for that. I can put where here as well. I told you. No, generally in a real code, what happens is most of the variables in Scala, they are put it as val even in the real time scenarios. Okay, why? Because Scala largely, okay, so depends on this immutability. So and we have to
No,
use
no.
it in the
Here we are creating another set. We are assigning that one set to another set.
correct.
But
Okay.
in same set, after if you change that val to var,
Okay.
same set, it allows us to modify.
You are saying that you are doing this, right?
Yep.
I'm asking this. Even in this case, it might appear that it is modified. That is not getting modified. Let me explain what happens. So might be. So that's
No.
what I.
You please
No
change
problem.
that var. Var is not required here, right?
One. I'll come to that
Second one.
point. 1 minute. Yeah. I will discuss that as well. Okay. This is what your point is. Okay. Now when you print it, you are saying that this original list is modified, right?
Yep.
But that won't be the case, Madhu. I will explain like how it works in memory. Let me give the analysis. When it is immutable never behave in that way. That is not how it has to behave. You got it, right? What happens, I will explain so that you get a perfect idea.
Okay.
You are saying that 100 is added. You are assuming that this old list is getting old set is sorry not list old set is getting modified as set, but that is not true. What happens here? Let me explain to you. Okay, and explain here itself. I can explain. I don't need a paint here because we have a drawing tools here. Now, what happens in this case when first time in this at this point? Okay, let me erase this quickly. I will show you now. See here. At this particular thing, okay, you are trying to. What happens? One object is created for HashSet. Assume that this is HashSet object, and all that data, whichever you are populating into that HashSet, will be stored into the HashSet. I'm just giving you a quick idea. Okay, here you have the data. Got it right? You have some one, you have some two. Order might be different. I'm just giving a quick analysis because it's not about the data; it's about object part. Now this has some address, or you might think this as hash code. Now what happens? This hash code is assigned to which one? This reference, right? The first reference is set. Now what happens in this case? This 100 is stored into this set here. Now here, 100 is stored here. Understand? Now set is pointing to this. Now all that other data also will be present in this. Just for time being, think that. Okay. Now after that, what you are doing now? Now you are trying to append some data to the set, adding some data, inserting some data into the set by applying plus operation, concatenation operation. Okay. Now what happens? You might be thinking, suppose there is 100 inside this asset. It's not the address. Okay, don't get confused. 100 is there here. You might be thinking, so this is our old set. Now to this old set, you might be assuming this 100 will come and sit in the same object. That is your expectation, if I am not wrong. Correct? Madhu, yes or no?
Yeah.
But that doesn't happen here. That is not true. In immutability, in case of immutability, now what happens? You try to modify the set, right? Has set. A new object is created now. What happens is a new object is created. All the data that is there in the old object, that is copied to this. Even if you put var also, that one, that three, okay, that's 5, okay, that's 6, and finally your newly added 100 is added to the new object. This 100 is added to this, and the other old data is copied to the new object. This has a different address again. Don't think 100 will be there for this. Assume that this has a 101. Now what happens? It will try to what? It will try to assign this set instead of 100. It will replace the reference here. Instead of 100, it will put 101 here. Now you see this old object doesn't have reference now. To this old object, the reference is removed, but this is not modified. This is still intact. There is no change in this. But what happened when you try to modify this object? Whatever JVM have done, it created a new object by copying all the old data into that. At the same time, that new data is inserted. A new address will be there for this, and that is copied to the reference. What it displays. This is what happens. You put val or you put var. But the point is, when you put val, it doesn't allow you to modify again. When you put var, it happens anytime, any number of times. So this is what, in this way, the concept of immutability is still intact, Madhu. There is no effect for immutability, even if you put var here. Somebody please mute the machine unless we are talking. You got clarity here, no? Of course, you can remove that var. Okay, I'm removing this var. You don't need var here, as suggested by you. This is what happens when you put var as well, or this is what happens when you try to modify this. Do you understand this, Madhu?
Yeah, I got it, bro.
Okay, still I think I can still prove to a point. Let me just show you that as well. Probably I can do one thing for you.
Yeah,
No problem.
I have seen that using that hash code. It is different.
Okay, let me prove that to you, okay? Because if not, even the others might have some idea, so that you know, if they still have some doubt whether I am doing any magic and I am trying to sell something. So to make sure that to prove that point again, apply hash code on set. If you print set, it will always print the data. And if you want to know the address of that first object and second object, apply hash code. Then for 2 times, if you are seeing same address for first time and second time, means we are not, the data is getting modified. But for first time you are seeing one address, and for second time you are seeing some other address, means definitely a new object is created. It is not trying to modify the old object. That's what happens here, Madhu. You got it right? Okay, let me run this and let us observe this. Can you see there? For the first time when you created that HashSet object, the address is -11260 something, which ends with 81. But when you modify, you are not seeing the same address, but you are seeing some other address, means a new object is created and that modified data is put into that new object, but the old object is not changed. That's what the concept of immutability here is. You got it right. If you put var, if you don't put var, if you just try to modify the same reference, so but still whenever you try to change this immutable object, then what happens? That is not modified, but a new object is created. That's what the concept of immutability. And this change is happening at memory level so that you cannot see. That's why when you apply hash code, that gives you a clear understanding here. If you see there, is it clear to you, Madhu? Now at least everybody has to agree here. Understood now?
And this point onwards, it will refer only the new object. Am I right?
Pardon?
And that point onwards, it will refer only the new object, but it doesn't
Correct.
refer
Now this is
old
referring to
object.
new object. That's why
In that case, that old object memory will be wasted, right? Is there any garbage collection like to remove that?
that goes to the garbage collection. It's not wasted. It goes to garbage collection. It's like, you know, going to a hotel and ordering a food. Suppose you eat one food in one plate, you put it aside. The cleaner will come and clean it sometime when you are eating it. Okay, you will be eating in the new plate again when you order another dish. Got it right? So
Okay.
goes to garbage collection. That won't be staying there for us. Okay. Is that clear, Madhu?
Yep.
Is that clear to you?
Yeah.
So now you are, this should be more clear for everyone. I think Is that clear to all of? That's what I thought to explain. I am trying to tell that same thing. I tried to explain without drawing the diagram, but finally, what is it? Your doubt made me to draw this diagram. Of course, it's not beautiful, but I hope this is enough to understand the concept, right? Clear, sir? Or anybody still has any questions on this?
I'm clear.
Okay, sir. This is the idea about this HashSet. Tomorrow, I thought to finish all that stuff, remaining two also. But as you know, right, we got into the other. These are all important to learn, okay? Because same concept is applicable even in Java also, if it is immutable, okay? But in Java, all collections are immutable, okay? Only string and these classes like what do you call wrapper classes, they are immutable, but others are mutable, okay? So this is more specific in Scala, this concept of immutability and mutable. Is that clear to all of you, sir? So you can test it quickly and then we can switch off the session for today, sir. Uh, any more questions? Any more questions, sir? Bharat, sir, Prasad, or okay, Srikant,
No, sir. It's
Sudarshan.
clear. It's clear. Thank you.
Somebody, some caller is there. I don't know if he is our session, our guy, caller 01. Is it Madhu or Rohan? So, fine, sir. We'll stop here. Tomorrow, we will get into the next one. Probably, we finished today this stuff as set, and we got a clear idea about this stuff, right? So, this hierarchy starts with what's a traversable iterable set, hash set, bit set, and list set. And sorted set is a tritalian that has a child tree set. We'll see all this stuff, right? Okay, good night.